Okay, so today we're starting Chapter 8, and Chapter 8 is on arithmetic and geometric sequences and series. In 8.1, we're just going to focus on today on arithmetic sequences. So a sequence is when you have a list of values. That is called a sequence. So if we look at the first one, what do you notice? How are we getting from 5 to 10, 10 to 15, etc.? Do you notice the pattern? And did you say that if you just add 5 plus 5, you get 10, and if you add another 5, you get 15? So the pattern is to add 5. So we can continue the pattern because we know that we're adding 5. So we could continue and say 20 and 25 and 30 and so on. And if the pattern is that you're adding something to get to the next term, then that is called an arithmetic sequence. So the first one is an arithmetic sequence because the pattern is that we're just adding 5 to get to the next term, the value of the next term. In number 2, it doesn't look like it that we're adding the same thing. Here we're adding 3, and now we're adding 6, and now we're adding 12. So we're not really seeing a pattern where you're adding the same number. So we're not consistently adding the same number. But did you notice the other pattern? That the pattern is we're multiplying by 2. So if you multiply 3 times 2, you get 6. And then 6 times 2, you get 12. And 12 times 2, you get 24. So obviously we can find the next few terms by just multiplying by 2. So the next term would be 48. And then we could multiply that by 2. And we could keep on going. When you're multiplying the same number over and over, that's a geometric sequence. So this is not an arithmetic because you're not adding the same number over and over. In the next one, can you see that we're going down 3, down 3, down 3 each time? So that means we're technically adding a negative 3 each time. So we could add a negative 3 and we get 3. Add a negative 3, we would get 0. Add a negative 3, we get negative 3. And we can continue the list because we know the pattern is that we're adding a negative 3. So because we're adding the same number over and over, this is called an arithmetic type sequence. In the next problem, you can see that we're not adding the same number over and over again, and we're not multiplying. We're not multiplying by 2 or multiplying by 3 or multiplying by 1/2, multiplying by 1/4. So we are this pattern is just we're adding 3, then we're adding 4, then we're adding 5, we're adding 6. So we see the pattern. We're adding the next consecutive number. So we know that we could add 7 to get 27. Then we're going to add by 8 to get 35. So because we're not multiplying by the same thing over and over, it's not geometric. And we're not adding the same number over and over. So it's not arithmetic. So this one is neither. It's not arithmetic, it's not geometric, and it's neither geometric or arithmetic. So again, to be arithmetic, you have to be adding the same number over and over and over again to be an arithmetic type sequence. So let's look at this arithmetic sequence. Do you see the pattern? Do you see what's happening? If it's an arithmetic sequence, that means we're adding the same number over and over and over again to the next number. So what if I asked you to find the next 3 terms? Well, you can see that we're just adding 2 each time to get to the next one. So obviously the next one would be 9, 11, 13, 15, 17, and we could just go on and on and on because we know the pattern. The number that you're adding over and over and over has a vocabulary word. That is known as the common difference. So the common difference is D is equal to 2. So we're adding 2 over and over and over again to get to the next term. And that is known as the common difference, and we use the letter D for the common difference. So you can see that they're 2 apart. And then we also need to know notation. So for an example, we could say the first term has a value of 3. And we could write the second term, right? So the first term has a value of 3. And we could say the second term has a value of 5, and so on and so forth. Well, a lot of times in mathematics, as you know, we don't like to write a lot of English words. We prefer to write notation that says the same thing. So we use the letter A and we use subscript. If we're talking about the first term, then we use subscript, and then the value of that term is what it's equal to. So this is A sub 1 equals 3 is just mathematical notation that says the first term has a value of 3. So how could we write this notation? The second term has a value of 5. We would say A sub 2 has a value of 5. That means the second term has a value of 5. So understanding the notation is super important. Don't forget, you can stop and go back and rewatch and take notes. So what if I said A sub n equals 13? And I said n equals what? Isn't that, am I not asking you what term has a value of 13? So if you look, this is the value 13 that's in the sequence, and we want to know what term is that. So we've got the third term, we have the fourth term, the fifth term, and the sixth term. So we could say that n equals 6, meaning that the sixth term has a value of 13. So understanding that notation is very helpful. So what if I said find A sub 6? What does that mean to you? Find A sub 6. In the context of arithmetic sequences or sequences, we're asking you for what is the value of the sixth term. So 1, 2, 3, 4, 5, 6. So this is the sixth term, and the sixth term has a value of 13. So understanding what the notation is asking you is super important. Here we have an arithmetic sequence rule. And this is a rule that when you have a sequence, you can find out what the rule is that would give you that sequence. It also allows you to jump to the 50th term or the 100th term, and you can find the value of the 20th term or the value of the 60th term by using that rule. So the D is the common difference. Remember, the D is the common difference. And that is what you're adding to get to the next term. So in this particular sequence, can you see that we're just adding 3 to get to the next one? We're adding 3 to get to the next term. So we could then know that it's 15, then it's going to be 18, then it's going to be 21 and 24, etc., because we know the pattern is adding 3. So here the common difference would be 3 in this problem. The D would be 3 in this particular problem. So understanding what the notation means. So this unit is really high in notation. A sub 1 means we're looking for, that's the value of the first term, right? So A sub 1 means what's the value of the first term. N is the term that you're searching for in the sequence, and A sub n is the value of that term. So these two are connected. So let's find A sub 10. So to find A sub 10, we can use the formula A sub n equals A sub 1 plus n minus 1 times D. We know the common difference is to add 3, so we know D is 3. So D equals 3 in this problem. And then what's the value of the first term? Isn't 3 the value of the first term? So we know A sub 1 is 3. And they want us to find the value of 10. So remember, n represents the term. So n is 10. So we want to find the value. So A sub n is the value of the 10th term. So we want to find the value of the 10th term, and we just plug in the value of the first term. We are looking for the 10th term times the common difference. So we just plug in what we know. So again, we know the first term has a value of 3, so that means A sub 1 got replaced with 3. We know the common difference happens to also be 3. and we are searching for the value of the 10th term. So we want to know what is the value of the 10th term. And then we can just do the math. So this is 3 plus 9 times 3, because 10 minus 1. So that's 3 plus 27. So that means the 10th term has a value of 30. So the 10th term has a value of 30. You certainly could have just added 3, added 3, added 3, and just kept on going, right? You could have said 15, and then 17, and then 20, and then 23, and 26, and then 29, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think I made a mistake there, right? 12, 3. Oh, I made a mistake right here. This is 18, and then this is 21, and then this is 24, and then this is 27, and then this is 30. Oh, the 10th term has a value of 30, so the 10th term has a value of 30. But look at how cumbersome that is. So instead of doing that, we can just use the formula to find the value of the 10th term. Well, another thing that we can do is we can write the rule that gives you that sequence. So we can write the rule that's given that sequence. And when it says write the nth rule for the nth term, then we can, so I'll write it up here, write the rule for the nth term. So we're going to use the formula a sub n equals a sub 1 plus n minus 1d. So you want to memorize that formula. When you're trying to write the rule, you only need to tell me what is the value of the first term and what is the common difference. You only need those things when you're writing a rule. And isn't the first term have a value of 3? And didn't we say that what we're adding over and over and over is 3? So the rule is a sub n equals 3 plus times 3. And then you should always simplify. So we're going to distribute, and then we're going to combine like terms. So our rule is 3n. Let me prove to you that that is the rule. If you plug in 1 for n, so if you plug in 1 for n, that would be 3 times 1, and that would give you that the first term is 3. If you did it again and you plugged in 2 for n, that would give you 3 times 2. That would give you the value 6. Notice how we got 3 for the first term, and when we plugged in 2, we got 6 for the second term. If we did it again and we plugged in 3, a sub 3, that gives us 3 times 3. That would give us 9 for the next term. So notice that this rule, when we plug in 1 or 2 or 3 or 4, it will give us the value of that particular term. And so that's called the rule of that arithmetic sequence. Here it asks you to write a rule for the nth term. In order to write a rule for the nth term, you only need 2 pieces of data. You need to know what the value of the first term is, and you need to know the d. So notice that they gave us the d. We know the d is 4, but we don't know what the value is of the first term. So we're going to use this information that says, so we need to find a sub 1. So we cannot write a rule yet until we know what a sub 1 is, until we know what d is. And so far we know d, but we don't know what a sub 1 is. So we're going to use this piece of information to help us find a sub 1. So in order to find a sub 1, it says the 13th term has a value of 42. So that means the 13th term has a value. So the 13th term has a value of 42. So remember, this is the term, and this is the value of that specific term. So we can plug in that information. So 42 is the value of the 13th term. And we know the common difference is 4. So then we've got an equation with one variable. 13 minus 1 is 12. 12 times 4 is 48. And then can't I use my algebra skills? Subtract 48 from both sides. And doesn't that tell me that a sub 1 equals negative 6? So now that I have my a sub 1 and my negative 6, now I can go ahead and write the rule. And I can say a sub 1 equals, I can plug in a sub 1 now as negative 6, and I know d is 4. And then I distribute, because when I'm writing just the rule, when you're writing the rule, I only need a sub 1 and d. That's it. That's what you need only when you're writing the rule. So I had to use this information that they gave me just to be able to find what a sub 1 is. And then you just always distribute and simplify. You can never leave a rule unsimplified. So that gives me 4n minus 4. Combine like terms. We always like to put our variable first. Doesn't technically matter, but that is your rule for that particular arithmetic sequence. So this is called the rule of the sequence. So if you plug in 1, 4 times 1 minus 10, that would be negative 6 would be the value of the first term is negative 6. If you plugged in 2, that means the next term, the second term, that means the second term has a value of negative 2. So if you plugged in 3, that means positive 2 is the next term. If you plugged in 4, that means 6 is the next term, right? So this rule allows you to find the sequence. And you can jump ahead as well. So this rule gives you that particular sequence by plugging in 1, plugging in for the second term, plugging in the third term, plugging in the fourth term, and then you get the value of each of those terms. So that's why we like to have the rule of a particular sequence, because we can also say, well, what about the 100th term? What would the value of the 100th term be? So once we have the rule, it makes it easy to say, hey, what is the value of the 100th term? So we do 4 times 100 minus n, because n represents the term. So it should be a 10. So that means 390 is the value. So 390 would eventually be the value of the 10th, 100th term in the sequence. So the 100th term would have a value of 390. So a lot of notation to understand. Let's look at the next one. Here we have, again, they want us to write the rule. So in order to write the rule, we need to have just the a sub 1 and the d. Right now, they didn't give us anything. We don't have the d, and we do not have the a sub 1. So we do not know the d, and we do not know the a sub 1. We do know that the 7th term has a value of 58. So again, a sub n equals a sub 1 plus n minus 1 times d. We know the 7th term is n. So that means the 7th term has a value of 58. So 58 equals a sub 1 plus 7 subtract 1 would be 6d. So we have one equation. Then we're going to do it again, but we're going to do it with the second piece of information. Here it says the 11th term has a value of 94. So if we take a sub n again, remember the 11 is the term. So 11 is the term, and it has a value of 94. So this is the value. So this is the value of the 11th term. That's what the n and the a sub n represents. It's the term and its value. So the 11th term has a value. So the 11th term has a value of 94. And then if we simplify that, doesn't that give us a second equation? And what we've created is a systems of equations. And we can solve that system by elimination method. Right? So can't I just multiply everyone by a negative? Right? And then can't I add those two equations? That was back in first semester when we did systems of equations by substitution method or elimination method. And then that's going to give me 58 and 94. So 94 and 58, and I subtract those. So that's going to give me 36. Negative a sub 1 plus a positive a sub 1 drops out. And then that leaves me 4 d's, right? And then I can divide both sides by 4. And I now know that my d is 9. And then once I know that d is 9, can't I go back up to either equation? I'm going to go back up, I guess, to this one. And I'm going to plug in place of d. I can now plug in 9 because I now know that d is 9. So I can plug in 9 for the d because we just found out that d is 9. And that will help me find a. It's a lot of algebra. So it's a linear equation. Subtract 15 from both sides. That gives me 43 equals a sub 1 if I didn't make a mistake. And so now I have my two pieces of information. So now I can actually write the equation. So remember, we were trying to write the rule or the equation. So now I know what my d is. I forgot what d was. What did we say d was? D was 9, and we just found out that a sub 1 is 43. So we can go back to the rule. And remember, when you're trying to find the rule, we just plug in a sub 1 and d, and we now know what a sub 1 and d is. So we can say the rule is, so a sub 1 is 43, and d is 9. So again, we use this to create two equations. And then once we had those two equations, we had a systems. We solved the systems by elimination so that we can get our d and our a sub 1. And now we can actually write the rule. And then we got to distribute and simplify. So a sub n equals 9n plus 34. And that's your rule of the sequence. So that is the rule of the sequence. So hopefully this will help a little bit. You can read the book a little bit. But hopefully we can clarify if you were taking the test today. Okay, ciao, ciao.